Recall that the expression in the form of x to the n power is called a power and represents the result of multiplying x by itself n times. X is the base and n is the exponent. The word power is also used to sometimes refer to the exponent. So as we look at the example here, it says that 3 is considered the base. 3 is the base here. The exponent is 4, and what that is telling you to do is to take 3 and multiply it times itself 4 times. So 3 to the 4th power means 3 times 3 times 3 times 3. When you multiply 3 times itself 4 times, you get 81. Common mistake is to try to say that 3 to the 4th power equals 12, because for whatever reason people see 3 and 4 together and they want to multiply just 3 times 4, and this is not true. 3 to the 4th power means take 3 times itself 4 times. We can do the same thing with variables. X to the 3rd times x to the 4th. Well, x to the 3rd power literally means that you take x times itself 3 times. So it would be like x times x times x. And x to the 4th power would mean x times itself 4 times. So x times x times x times x. And when I count that up, I see that there are 7 x's there. 1, 2, 3, 4, 5, 6, 7. So x to the 3rd times x to the 4th could be rewritten as x to the 7th power, because it would be the first 3 x's times the last 4 x's. Same with the y's over on the other side. Times y to the 5th, that would be y times itself 5 times. And as I count that up, I see 6 different y's, so that would be y to the 6th. So instead of writing out all these y's and x's, how can we come up with a generalized rule for multiplying variables with exponents? So we have the key concept, product of powers. To multiply 2 powers that have the same base, add their exponents. So when you multiply terms with exponents, you are adding the exponents. And you can see above exactly why we are adding the exponents. So, example would be, if we have b to the 3rd times b to the 5th, we would add those exponents together. So 3 plus 5 is 8, so we would say it's b to the 8th. G to the 4th times g to the 6th would be the same as g to 4 plus 6, and 4 plus 6 is 10, so that would be g to the 10th. So let's do some more complex ones here. Simplify each expression. So 6n to the 3rd times 2n to the 7th. Now the bases, the numbers 6 and 2, those are bases. They are not exponents. So we are not going to add those. We are going to multiply the bases. We are going to take 6 times 2 to get 12. But n to the 3rd and n to the 7th, those are variables with exponents. So we are going to add those exponents, so that would be n to the 10th. So 12n to the 10th would be your answer on that. The next one, 3pt to the 3rd power times p to the 3rd t to the 4th. So there is not another number in the second set of parentheses to multiply times the 3, so I will just bring that down. Then it has p and p to the 3rd. Now p is the same as p to the 1st power. There is actually a 1 there with p to the 1st power. So then when you do p to the 1st times p to the 3rd, you're going to get p to the 4th, because 1 plus 3 is 4. And then t to the 3rd times t to the 4th, we would add those exponents together, and that would be t to the 7th. And over on example 2b, negative 4r x to the 3rd, or x to the 2nd t to the 3rd times negative 6r to the 5th x to the 2nd t. So we will multiply the integers negative 4 times negative 6, because again, they're not exponents. We just multiply those together. That is 24, positive 24. And then I have r to the 1st power. Remember, that's r to the 1st power times r to the 5th power. That would be r to the 1 plus 5 or 6th power. And then x to the 2nd times another x to the 2nd. That would be x to the 4th, because 2 plus 2 is 4. And then t to the 3rd times t to the, again, there's t to the 1st. And that would be 3 plus 1 is 4, so t to the 4th. And that is how to multiply terms with exponents, is that you add the exponents together.